Evaluate the limits, and let's do it. Limit 1 first. A is limit as x and y approaches 0 and 0, 3x squared y over x squared plus y squared. I see that the order, if I plug in 0 and 0, I get form 0 over 0 and indeterminate form, but I see the order of top, or the order of 0 in top, is higher than the order of 0 in the bottom. So what I do is I try the basically the polar coordinates. And then by plugging in, the limit becomes, as r goes to 0, theta goes to, I don't know, the limit becomes 3r squared cosine squared theta r sine theta over r squared cosine squared theta plus r squared sine squared theta. And that is limit as r goes to 0 of 3r squared cosine squared theta, and the bottom becomes r squared if you factor r squared and using Pythagorean theorem. Let's do r times r squared. You get r squared, and so you simplify this to get limit as r goes to 0 of 3r times cosine squared theta sine theta. Now, r goes to 0, but cosine squared theta, sine squared theta, where does that go? And it's obviously oscillating, but is it bounded or not? And so I check, and cosine squared theta, 3 times sine theta, is between 3 and negative 3. But that's not just this, it's multiplied by r, so I can multiply it by r. And then remember that limit of 3r as r goes to 0 is 0. Same thing as that. Negative 3r is equal to 0. So by squeeze theorem, this limit is equal to 0. The middle one is equal to 0 as r goes to 0. And so the limit exists and it's equal to 0. And so basically when you're saying that that you're finding a limit of two functions and one of them goes to 0 and the other one is bounded like this was, and then by squeeze theorem it's going to be the limit of the product is going to be 0. So the next question is this one. Limit of x squared y over x to the 4th plus y squared as x and y goes to 0 and 0. Again, as I plug in, I get form 0 over 0. Let's try to find two paths that gives us 0. Finding y equal to x squared because that neutralizes the, and so over that limit is going to be limit of x to the 4th over x to the 4th plus y to the x to the 4th as x goes to 0, and that is a limit of x to the 4th over 2x to the 4th, x goes to 0, that is 1 over 2. Another path is y equal to y equal to mx or x, and limit is going to be equal to x to the 3rd over x to the 4th plus x to the 3rd as x goes to 0, and factor mx to the 3rd, and you end up with 1 over x plus 1 as x goes to 0, and this is equal to 1. So the two paths gave me two different answers. limit values. So it does not exist. The limit does not exist. And so sometimes people ask, how did you figure this out? And so basically, your for the limit to exist, a lot of times I'm looking for the zeros on top to simplify with zeros in the bottom, and this gave me the feeling that they are not going to simplify, and so that was the reason. Is this the only way to evaluate this limit? The first one, no. There are other ways that we can discuss also in class. And so let's see. I'm giving you an alternative method of evaluating limits of 3x squared y, x squared plus y squared, as x and y approach 0 and 0. So the trick is that I can see if the y wasn't there, I would get 3x squared over x squared plus y squared, right? And so basically 3x squared over, or even that's the part that gives me the feeling, x squared over x squared plus y squared is less than equal to, I'm making it a little bigger, x squared plus y squared divided by x squared plus y squared. I made the numerator a little bit bigger, and that is equal to 1. So now I multiply this by 3, 3x squared over x squared plus y squared is less than equal to 3. And then if I basically, and also I can put this down in here, it's bigger than 0, bigger than equal to 0. Now if I multiply everything by a y, the middle one is the expression I'm finding the limit of, the function I'm finding a limit on, and limit of 0 as x and y approach 0 and 0 is 0. Limit of 3y as x and y approach 0 and 0 is also 0. So the limit of the middle one, because this one is just elementary function, so the limit of middle one by squeeze through, limit of 3x squared y over x squared plus y squared is going to be equal to 0. So this is another method that you have to play algebraically and find something that works.